Hello friends, this is Praveen. Welcome to ITS workshop. As you know that we are discussing about methods of class objects. So we have seen toString, we have seen equals. Now let us talk about hashcode. So there is one method known as hashcode and it is in class object and it returns integer. So what is hashcode? It returns a hashcode integer value of an object so that the object can be used in collection classes that are hashing that use hashing, including hashtable, hashmap and hashset. So it provides some integer value, or we can say hashcode, that can be used by collection classes, especially the collection classes starting with hash. You can see, so hash table, hash map, hash set, these classes are using hash code. So hash codes are useful if you are performing searching, if you are performing sorting, and you are using these classes hash map, hash set and hash table. So let us see what is this method and what is the meaning of hashcode into it. So hashcodes are typically used to increase the performance of large collection of data. So if you have large collection of data and you want to perform some searching using that and you are using collection, then you should override hashcode. It will give you good performance for searching. Although we can think of it as kind of object ID number, it isn't necessarily unique. You can think it to be an ID number, but this is not unique. This for two object it can be same. So we uh, we are not saying that it is ID, but we can imagine it like an ID. Now collections such as hashmap and hashset use the hashcode value to an object to determine how the object should be stored in the collection. So during the storing of object, hashset and hashmap classes use hashcode, and during retrieval, so if you want to locate your object again from the collection, then it uses same hashcode. So hashcode is used during storing and during retrieval also if you are performing search operation. Let us see what else we have. So this is one method, hashcode, which is returning integer. That integer is something which is used for storing the object in collection and which is helpful for your performance when you want to retrieve that object from the collection. Now, in order to clarify this more, we can take one example. How this hashcode is working, we can see. Suppose you have given a task of collecting names of the guests appearing in your party or an event. So there are four people: Alex, Bob, Dirk, and Fred. They are appearing into your function or any event, and you are collecting their information. You are collecting their information on some piece of paper, you can say some slip. You are maintaining that piece of paper and you are storing in a box, in a big bucket, or in a big box. So anybody who is coming, you are taking their information and you are storing into a big bucket. So that's how you are storing the information right now. This is the first scenario. Now if somebody asks, suppose Alex comes back and asks, hey please would you give me my information or any information, would you give me my slip back to me? Then you again go to your big bucket, you search a lot. There are four people, it's fine, you can easily search. but if there are more number of people, like 1,000 people, you'll have to search from 1,000 slips, from 1,000 pieces of paper in order to get the correct one, which is Alex. So this is how we are doing. We are trying to store information, and we are trying to retrieve information from a single large bucket. This is the first scenario, and obviously you can see for more number of people the performance is really bad. So let us try to compare this with the hash code. So whenever any object is created, we get hash code associated with that object, and that hash code is unique. It means that object is being stored in a unique slot. Now if you want good performance, we can consider scenario number second. In this second scenario, for storing information and for retrieving information, we can consider one hash code algorithm. Like this algorithm can be any one efficient algorithm of your choice, and for this example we can take calculating integers. Like if name is Alex, so name starts with A, and the integer for A is 1, like A1, B second, C3, D4, and so on. So A is 1, L is 12, E is 5, X is 24, and the integer generated for Alex name is 42. So 42 is her hash code, and the process of generating this hash code is our algorithm, and these are the keys which we want to store. These are the information which we want to store. So for Bob we can calculate 19, for Dirk we can calculate 42, for Fred we can calculate 33. So now we get some integer. Whoever comes, we just breaks down his name, and we calculate according to letters appearing his name, and we get some integer. So what happens if I give you Alex name thrice? You will give me same number 42 for Alex. So now we try to store these information using hashcode algorithm. So in this scenario, if people are coming, people are approaching to you, and you have got not only one bucket. In last scenario we got only one big bucket or one big box. Now we have multiple boxes. Here you can see 5 boxes are there, and I'm calculating hash code for all coming people. So if hash code is 19, then I'll put for name Bob hash code is 19. So I'll mark this bucket as 19, and I'll put Bob's name or the information paper slip which contains Bob information in bucket number 19. There is bucket number 33 which has got Fred. There is bucket number 42 which has got Alex and Dirk both. Now you can see for Alex and Dirk we get 42 and 42 both. So what happens? Now if somebody comes to you again and asks, hey, can you please retrieve my information again, can you give me my paper slip? Then you just need to calculate their hash code. Suppose hash code is 42, then you approach the bucket number 42 and you search for the information Alex, and you provide the paper slip back to Alex. That's how you do it. Now if you compare this scenario to the previous scenario, we got only one big bucket. So if 1000 names are coming, you are searching 1000 paper slip in single big box or single bucket. And now in this scenario, if thousands name are coming, so definitely you don't have 1000 bucket, and you don't even have one big bucket. We have some, you can say like 20 buckets or 10 buckets depending on the hash codes. the variety of hashcodes which we are generating. So we just need to get into the right bucket, then we'll get the right information. So our task is divided into two steps. Now searching is divided into two steps. First step, you just need to find the right bucket, and second step, you search the bucket for the right element using equals method. Now, so your hashcode method, your hashcode, which is the integer, in this case 19, 33, 42. So your hashcode tells which is the right bucket you are supposed to perform your search. And your equals method, which we have seen in last video. So your equals method tells how to compare one element with other element. So you got the right bucket, now you just need to see the right element using equals method. So this is how these two methods are working. Hashcode, let me say it once again, hashcode is giving you the right bucket, and since we don't have one bucket, we have multiple buckets. So our storing information and searching information, it is giving us good performance. So that's how it works. I hope you got this. Let us now see how to implement hashcode. One more point we can keep in mind: if two objects are considered equal using the equals method, then they must have identical hashcode values. So let us see how to implement hashcode. It's very easy. I have two classes here, one test class which has got just main method, and one student class. So student class is having two variables, one is roll number, other one is name. This is constructor accepting roll number and name, and these are getters and setters. So in last video we saw how we can write equals method for a student. So we are just saying equals, and we are checking whether object is of student type, and we are giving condition for roll number. So if roll number is equal, if one object's roll number is equal to another object's roll number, it means they are equal, otherwise they are not equal. That's how we use equals method. Now let us come to hashcode method. So before hashcode, let we have these two objects, student1 112 John, student2 112 John. Now these both objects are equal object according to our condition because their roll number is equal. So let us try to print their information. So sys out, and I want to have information for student 1, and second I want to print student 2 information. So student 1, student 2, let us see what we get. So you can see this is my package, this is my class name student, and this is @ and then hexadecimal representation of hashcode. So we are getting different hashcode for both these objects. So that's not good. If you are implementing equals, then you must implement hashcode also. So let us provide hashcode for it. Public int hashcode, and it should return some integer. So we should not directly say some integer, returning some integer. That will be equivalent like if I say return 45, This is totally legal method, acceptable, no problem, but it is highly inefficient. It will just give a big bucket, one single big bucket for your searching. So we won't do that. We'll just go ahead with roll number. So I can say this dot roll number multiplied by 45. Not 45, let us make it 5. You can make it 45 also, and in right now we are not too much concerned about the algorithm part. We just want to see how to implement basic hashcode method. So if I say this dot roll number multiplied by 45, I'm I want to say that my hash code will be according to roll number. My hash code is somewhere or other dependent on roll number. So it should be 5 times of roll number. So let us save it, and now a last result we got different hash code. Now let us try to run this again. Now if you see that I have written hash code and I want to run it again, so I was expecting different result for it, but there was one mistake. We said hash code and C is small here, so it is like general method. We are not really overriding. So make sure you make hash code and C should be capital. So now store it, and now we try to run it again. Now you can see that at the rate 230 for both object. So if two objects are equal according to your equals method, there should be hash code, they should have same hash code. So now we can see for both object we have same hash code 230. It means these two objects will we will search in bucket number 230 for this object. So that's what it means. So and definitely there can be more than one object having same hash code, but it doesn't mean that they are equal. But if two objects are equal, they should have same hash code. That's how it is. So if two objects are considered equal, they must have identical hash code. One more point you can keep in mind, that keep variables non-transient, or if they must be marked transient, don't use them to determine hash codes or equality. So especially when you are using serialization, deserialization, and you mark some variable as transient variable, now we know that transient variables are not considered for serialization. So these may give you wrong result. So like in this example, we have considered this roll number variable, and if this student class is using serializable and this roll number is transient, then you should never use this roll number in your hash code method. So this is also one point to remember. So always use non-transient variable to determine your hash code or equality. So that's it from my side. If you like this video, please click on like button, subscribe for more videos like this. Thanks for watching. Thank you.